Welcome back to the deep dive. So we got this really fascinating set of field notes sent in by one of you, actually. It's from a gardener, someone really meticulous,
Right.
trying to master plant propagation. They're really tricky stuff, and spoiler alert, they kept failing. But today we're digging into how that failure turned into something, well, pretty amazing, actually. Right into the weeds, you could say.
Yeah, that's a great way to put it. And that's our mission today, really, to look at this specific attempt with ferns. Because you got these two methods, right? The super controlled, high effort lab approach, which just didn't work out. And then this almost accidental, totally passive thing that did. And the big takeaway, I think, the nugget for you listening is sometimes the best answers aren't those complicated ones. Sometimes you just need to let nature do its thing.
Okay, yeah, let's definitely unpack that because the starting point here is key, isn't it? It's all about frustration, failure. This gardener was going after spore propagation for ferns, which I gather is not like just sticking a seed in some soil. It's specialized.
Oh, absolutely. Highly specialized. When the notes say they haven't yet mastered propagating them via spores, that's putting it mildly. We're talking serious effort here.
Yeah.
Months of it. You need sterile conditions, think lab-grade stuff.
Petri dishes and autoclaves.
Exactly. Autoclave dishes, maybe special growth media like agar, perfect humidity control. You're basically trying to germinate microscopic dust, hoping it turns into this tiny little green thing called a prothallus, and then maybe into an actual fern. It's complex.
Right. So all this high-tech controlled effort, what were the results?
Based on the notes, a big fat zero. Consistently, weeks, turning into months, apparently, of managing these sterile boxes, checking temperatures, light levels, all for nothing. No germination.
Wow.
Yeah. It's kind of the definition of sophisticated failure, isn't it?
Yeah.
And it really shows how sometimes trying to force things with human control, well, nature has a narrow window for that to work.
And I think the notes mentioned something about the timeline, 6 weeks of this intense effort with absolutely no results.
That's right, nearly 6 weeks. That detail really sets up the contrast, the aha moment, because, usually when something hard fails, we just try harder.
Double down, yeah.
But they didn't.
Nope. They shifted to what the notes call a much simpler, almost passive approach. And this is the kicker. They just left an open container outside.
Just an open container, like a bucket or something.
Seems like it. Unsterilized, no fancy medium, just out there, exposed to whatever.
That's about as low effort as it gets. It almost sounds like giving up, okay, nature, you have a go.
Pretty much. But what was happening accidentally was genius.
How so? What was that container doing?
It became the perfect spore trap. See, instead of trying to introduce specific spores in a lab, it was just passively collecting airborne spores from the surrounding environment.
Okay.
Think about how many fern spores are just floating around. Thousands per cubic meter of air sometimes. So this container, it was basically a landing pad. The wind did all the delivery work. It tapped right into the local ecology's dispersal system. Okay, so nature's delivery service, and how quickly did that work compared to the 6 weeks of nothing?
That's the really staggering part. The notes suggest it was fast, surprisingly fast, probably days, not weeks. Suddenly, 2 different kinds of ferns spontaneously sprouted and began growing just like common weeds.
Just like common weeds. I love that phrasing. It says it all.
It really does.
Yeah.
Minimal human effort, maximum natural process, instant growth versus months of controlled failure.
So the real skill here wasn't forcing the growth. It was just noticing it and figuring out what it was.
Exactly. Recognizing what the environment was already doing. Which brings us to the identification part, because it wasn't just random green stuff. They tentatively ID'd 2 species.
Right. Let's get into that. This is where we need to put on our botanist hats, like you said. Give us the visuals.
Okay, let's make these memorable for you listening. 2 distinct successes.
First up, the rabbit's foot fern. Davallia griffithiana. Sounds cute. What does it look like? Notes say triangle-shaped, lacy, delicate fronds.
Yeah, that's the frond. But the real giveaway for Davallia, especially this one, is the rhizome. That's the stem it grows from. It creeps along, often right on the surface, and it's covered in this dense, fully, light brown hair. Looks just like a little furry rabbit's foot, hence the name.
Ah, okay. So look for the fuzzy foot.
Exactly. And the fronds themselves are super finely cut, very dissected. Think almost like cilantro or parsley in texture. Very airy, very delicate, usually like shade.
Got it. Fuzzy foot rhizome, light, lacy fronds. That's Davallia griffithiana.
Okay, what was the second one? The contrast.
The Broad Sword Fern. Nephrolepis biserrata. And yeah, total contrast.
Broad Sword, Sounds tougher already.
It is. Much more
Yeah.
robust. Where the rabbit's foot is delicate and small, this one has long, arching fronds that can get pretty big. And the key difference in the frond structure, instead of those tiny, lacy bits, the broadsword fern has lots of large, simple leaflets. They're called pinnae, running up the main stem. They're kind of long, maybe slightly toothed on the edges.
Okay, I can picture that, like rungs on a ladder almost, but green leaflets. That's a good way to think about it. Much bigger components, much sturdier look overall. Nephrolepis ferns are tough. You see them around a lot, even in disturbed areas.
So, delicate lace versus a sturdy green ladder.
Yeah.
Davallia griffithiana and Nephrolepis biserrata. Knowing the names in these visuals, it makes it real.
Exactly. And it shifts your thinking, doesn't it? From how do I make this grow to, okay, what's already growing here and why?
But wait, let's pause here. Does this accidental knowledge actually help the gardener achieve their original goal? Like propagating a specific rare fern, they still can't control which spores land in the bucket, right?
That's a really sharp point. And no, it probably doesn't directly help them propagate, say, some rare hybrid they bought spores for. That sterile technique is needed for that level of control. But this accidental success gives them incredibly valuable ecological knowledge. Well, first, it tells them these two species, Davallia and Nephrolepis, are thriving locally. Their spores are everywhere. Second, the conditions in that spot, the light, the moisture, the temperature, are obviously perfect for these ferns. And third, maybe their future controlled attempts should try to mimic this successful passive environment, not just some generic lab standard.
Ah, I see. So it's not about controlling the source, but understanding the successful conditions. Identification becomes the first step to smarter control.
Precisely. It's observation informing manipulation, rather than just manipulation in a vacuum.
It really underscores the power of just watching. We tend to think value comes from hard work, complex processes, yet here, a bucket sits outside, and boom, ferns.
And it gets better. The final note in the source material really drives this home. While the gardener was actually writing these notes down, reflecting on the container success, they started noticing other ferns. It says they discovered several new fern species flourishing around my different gardening areas.
No way. So once they learned to recognize these two, their eyes were suddenly open to others that were there all along.
Seems like it. The container experiment didn't just grow ferns. It grew the gardener's ability to see. It makes you wonder about everything we dismiss as weeds, doesn't it? How many interesting species are just overlooked because they're common, or we haven't bothered to identify them?
Or haven't labeled them desirable. The success wasn't the growth itself, but the recognition of the growth.
Exactly.
Which does raise that bigger question, how much of what we really learn, comes from these highly structured experiments trying to force an outcome versus just being observant, noticing patterns that are already playing out around us, whether it's in gardening or, well, anything.
It's a fundamental difference in approach. The controlled method demanded knowing everything about the specific spore beforehand. The passive method just needed an open container and an open mind. One approach yielded nothing. The other yielded two named species and the insight that the whole garden was already a fern haven.
Wow. Okay, this has been a fantastic deep dive into what you called accidental botany. It's quite a story. We started with this dedicated gardener failing at the super technical spore stuff, sterile agar, weeks of effort, and we end up with two clearly identified successes.
The lacy, fuzzy-footed Davallia griffithiana.
And the bold, arching Nephrolepis biserrata.
All because they, almost unbelievably, just left an open container outside.
Yeah. And maybe here's a final thought for you, the listener, to chew on, something to take away from this. If two distinct fern species just popped up in an open container, totally unplanned, what kind of specific, maybe unique, maybe even game-changing knowledge is hiding in plain sight right now? In the weeds of your own work, your own environment? Is there some complex problem you're pouring effort into controlling that might actually have a simpler answer just waiting to be observed?
Wow.
Something that's already growing successfully if you just knew how to look. That's a great challenge. Maybe we should all stop pulling weeds, metaphorically speaking, for a bit and just look closer. You might find your own accidental success story flourishing there. Definitely something to think about. Thanks for joining us for this deep dive.